Okay, so this is the third video for this section, and we're going to do example number 3 here. It says find the volume of a solid formed by revolving R about y equals tangent x, y equals 1, x equals 0 about the x-axis. So before I do anything, I'm going to go ahead and draw this out. So I'm just making a notation that I'm revolving around the x-axis. And then I'm going to graph these functions. So the first one says y equals tangent x. So I know tangent looks like this. And I'm going to put in some points here. I know that tangent equals 1 at pi over 4. And tangent equals -1 at negative pi over 4. Okay, and then I also know that y equals 1 is a line that is going to look like, is a line that's going to look like this. I'm going to change this line up here. Use a different color. Okay, so it's a line going through this point. And finally, it says x equals 0. X equals 0 is the y-axis. So I'm just drawing out, what's going on here. And I see that these 3 equations bound this little area here. Okay, so remember, if we're revolving around the x-axis, I have a ghost function. So my ghost function looks like this, and I'm going to go ahead and highlight that for you. So now I can see kind of what's going on. And it said to use washers. So I'm going to use a different color again, just so this is clear. So I'm going to use this color, and I'm going to create a washer here. So this is basically what's going on. We have washers that are perpendicular to the x-axis. And we know when that happens that we're going to have to integrate in terms of x. So I know that this is going to be dx. So if I set up my equation, volume equals pi times r outer squared minus the radius of the inner function squared. And we know that this is going to be dx. So we got to fill this out before we do anything else. So what I'm going to do is I'm going to enlarge this one section here just so we can see. And we're going to work on R out and R in. So here is, whoa, I don't know what that was. That's kind of weird. I'm going to make these nice and straight, guys. Like, let's try to be nice as possible. Okay, and we have this situation going on. So let me just cap this off like that, and I'll erase the top. Whoops, don't want to erase that much. Just do a little bit there. Okay, so here is that region. I'm just enlarging this so that we can see kind of what's going on. Remember that this top line is y equals 1. The curve here, remember, is tangent x. Okay? All right. So my inside radius is from the x-axis up to the curve tangent x. So let's label this as Rn. And my radius outer of that washer is going to touch up at the line y equals 1. So this is R out. Okay, so I just wanted to show you a picture of what's going on. So the distance between the curve tangent x and the x-axis is Rn, and the distance between the outer function, which is y equals 1, and the x-axis is R out. Okay, so once you get that under control, it should be pretty easy. Okay, so let's work on R out first. So the radius is going to equal my top function, which, remember, we're doing R out, so the top function is 1, and it's going down to the x-axis, so that's 0, okay? So R equals 1, so therefore R squared equals 1 squared, or we can say R squared equals 1, okay? So I can put this inside the parentheses minus. Let's do Rn. Okay. So Rn, R equals, so the top function there, remember, is the line tangent x. So tangent x minus 0 because it's going down to the x-axis. So r equals tangent x. So r squared equals tangent squared x. Okay, so let's go ahead and put that one in. So 1 minus tangent squared x dx. Okay, so pi is hanging out here. Now I have to find my limits of integration. Remember, we are integrating in terms of dx. So when you're integrating in terms of dx, basically what I want to do, and I'm drawing this super duper fast, is I want the x values where the two hit. So I want this intersection point here and where it starts. So it starts here and ends here. So I want these values, right? I know this one's 0 because remember that was bounded with the y-axis and the x-axis. So the question is, what is this one? What I'm going to do is set the two functions equal. Remember that this is y equals 1 and this is tangent x. So if I set tangent x equal to 1, then I have to just solve. So x equals the inverse tangent of 1, x equals pi over 4. Okay, so this is going to be my upper limit. And remember we said that the lower limit is 0. Okay, so I'm going to plug those in. So once again, the lower limit is 0, upper limit is pi over 4. So now I have my volume formula. Volume equals, and I'm going to kick out the pi. I'm going from 0 to pi over 4 with my integration. And then I have 1 minus tangent squared x dx. So now it's time to integrate. And when I look at this, I know I don't have any integration rules for tangent squared x. And I cannot use substitution. Because if I take the derivative of that, that is not going to even be close to the leftover of dx. So I just have to be clever with this. I'm just going to make a little note. I can't integrate this. So what I can do, though, is use Pythagorean theorem. The Pythagorean theorem, or the Pythagorean identity from trigonometry, says 1 plus tangent squared x equals secant squared x. And if I get tangent squared x by itself, I get the statement that secant squared x minus 1 is equivalent to it. So what I'm going to do is I'm going to substitute in secant squared x minus 1 in for tangent squared x. So let's do that. So volume equals pi times 0 to pi over 4, 1 minus secant squared x minus 1. Notice I put that in parentheses so I don't lose that negative sign. So to simplify it again, before we integrate, we get pi times the integration of 0 to pi over 4. And then 1 plus 1 is going to give me 2. And then I get plus secant squared x dx. Now I am ready to integrate this. Okay. So if I integrate 2, I get 2x. If I integrate secant squared x, I know that's going to give me tangent x. And guys, I missed a negative sign, so I'm going to fix this really quick. This should be negative secant x. So let me fix that because the reason why that's negative is because of this. Okay, so fixing that really quick, we get negative tangent x. Okay, don't forget that I have to multiply this by pi, and I'm integrating from 0 to pi over 4. Okay, now I'm ready to go ahead and distribute the pi values. So we get 2 pi x minus pi times tangent x from 0 to pi over 4. Okay, time to do f at b minus f at a. So almost there. So f at b, I take the upper limit, so I get 2 pi times pi over 4 minus pi times tangent of pi over 4 minus 2 pi times 0 minus pi times tangent at 0. Okay, so 2 pi times pi over 4 is going to give me pi squared over 2. And then tangent at pi over 4 is 1. 1 times pi is pi. And then everything inside parentheses, 2 pi times 0 is 0. And then tangent at 0 is 0 times pi, which is 0. So everything in the f at a goes away. It zeroes out. So my answer is going to be pi squared over 2 minus pi. And that is the area, or the volume, excuse me. That's the volume of the washers creating that solid.